All right, so I am going to walk you guys through how to do a force diagram and the math that goes along with an inclined plane problem specifically. So let's just go through this, and so let's get some pens out so we can draw some forces acting on it. Now, I'll try and color code this, and I'm probably going to fail. Yeah, let's go with green. Boop. All right, so one of the big forces that we never can escape is the force of gravity. All right, so here's my buddy Robin. He's sliding down, I don't know, the top of a building, something like that. And so we've got the force of gravity is pulling him down. Other forces would be a force normal pushing off of the surface. And I'm going to guess friction is trying to slow us down. Now, you'll notice I do those a little smaller. It's because I don't want to bring too much tension to them because they don't matter as much when it comes to inclined planes. They're not the big deal. But you'll notice that if I draw Robin as my system, I usually replace my system with just a box. All right, so if I replace Robin as a box, well, friction is perpendicular to that, normal is perpendicular to that, but gravity is at an angle to that. And so what that means is that we're going to have to break up gravity. Okay, whoops, I erased the wrong thing. Sorry, I'm using a new program right here, so we'll see how this goes. So what we do with inclined planes is to make the math easier is we actually rotate the plane so that our y and our x, instead of being necessarily up and down, they are perpendicular to the surface or parallel to the surface. And so we just kind of give a little twist like this. And what that means is that our force of gravity is no longer in one of those two planes. And so because of that, it is at an angle. And so what we're going to have to do is we're going to have to break up into its components. And so this is where I am going to be drawing. All right, so that's too long. Darn it. I failed life. Where's my undo? There we go. We'll try this again. Like I said, try a new program. Sometimes you succeed in life, sometimes you fail. It is what it is. There we go. That's better. All right, so there's my force there. And then that would be my FGY. And then let's go blue for FGX. All right, so FGX. All right. So now when I want to evaluate what's going on, I care about the angle. So normally our angle here is theta. All right. And if you'll notice, I'm going to do some math derivation. I apologize. I'm going to try and keep this as straightforward as we can. So we've got, this is a right angle. If this is theta, let's call this angle over here alpha. Well, this is also a right angle right here. So, well, we know a right angle is 180 degrees for a triangle. And so we take away 90, that means that alpha plus theta must be equal to 90. So if that's alpha, this has to be theta. And since this is a 90-degree angle, that means this has to be alpha. So we kind of have some similar triangles here. And the big takeaway is this new setup that I have in green, blue, and red. And so if we look at the understanding of, say, sine of theta, all right? If we look at sine of theta, sine is defined as opposite over hypotenuse, which means I should not have picked red. I should have picked blue. Man, this is why I don't get paid the big bucks. All right, let's try that again. So sine of theta is equal to opposite over hypotenuse. And so we look at the opposite. Well, the opposite, so sine of theta, opposite is Fg of x, and the hypotenuse is the force of gravity itself. So if I rearrange this, I get Fg sine theta equals Fg of x. I don't know where all these little lines are coming from. It's so weird. This didn't used to happen. All these dots over the places. I don't know what's over that. Clean up here. It's bothering me. My OCD is going insane. All right, so that's your x component. Now this is different than the normal inclined plane because normally the inclined plane, or I'm sorry, the normal angle says that the x component goes with cosine. But because it's an inclined plane, we had to shift our axes. That's going to rearrange some things. So that's kind of what I tell myself. I said, hey, I messed with my world, so it's going to mess with my world. Then we have the cosine of theta is equal to adjacent over the hypotenuse. So cosine of theta, well, the adjacent is FGY and the hypotenuse is FG. So when I rearrange this, I get FG cosine of theta equals FGY. All right. So we have these new, I don't want to say the rules, but it's just a new way of looking at it. So when you have an inclined plane problem, X now goes with sine and Y goes with cosine. All right, so X now goes with sine and Y now goes with cosine, which is the reverse of what is normally true, because usually the X goes with cosine and Y goes with sine. But again, since we messed with it, but on inclines, X goes with sine and Y goes with cosine. All right, so since we messed with it, we're going to have some different arrangements. But then math is the same. You know, you're still going to use your trig, you're going to do some basic stuff. But what we use are sine, cosine, analysis, and what gets assigned to different things, that will be different. Okay, so I really just want to talk about that. Sorry about the new tech with the new trying for some stuff. But yeah, I hope that cleared up some stuff on the inclined plane issues. So as always, enjoy science and play more games.